Hi, in this video I'm going to conclude questions 3 through 5 from your homework, and that was using the rational root theorem. Again, I'm going to compile a list of possible zeros by taking the factors of the constant over the factors of the leading coefficient. And since this is 1, again, I really don't have to take the factors of the leading coefficient because anything divided by 1 is itself. So factors of 4 are 1, 2, and 4, and that's going to be the positive and negative values of that. So I have 6 possible zeros for this particular function. And again, there's really no way of knowing which one it is other than just to guess and check. And so synthetic division is the way to do that. And we're going to just pick any one of these candidates and plug it into the synthetic division problem. So I'm going to start with my favorite number 1. And I'm going to multiply and add, multiply and add, and I can already see that this one is not going to be a 0 because that adds up to 10. So again, we're going to strike the number 1 off the list and try another candidate. And I'm going to go with -1. -1 times 1 is -1. That gives me 0. -1 times 0 is 0. That gives me 4. -1 times 4 is -4. And that gives me a 0. When this is equal to a 0, you have found a 0 of the function because this is the remainder. And whenever a number is divided by its factor, or one of its factors, there's never a remainder. The remainder is 0. Now what you can do to find the other two, if they exist, is to rewrite this in its polynomial form. So it's going to be x squared plus 0x plus 4. And keep in mind that this is a factor, because anytime you divide a number by its factor, you get a factor. And if I set this equal to 0 now and look for those zeros, once again I'm going to see that this is going to be an imaginary root. And x is equal to plus and minus 2i, which is obtained by taking the square root of 4, -4, and extracting that negative and making it an I. And then the square root of 4 is 2, and of course those are 2 answers. But you can see that these are not rational zeros, and so my only rational 0 is x equals -1. Number 4 is the first question where we have a leading coefficient other than 1. So this will be just slightly different than the others that we've done. But we're going to take factors of 8, which are going to be plus and minus the 1, 2, 4, and 8. And factors of 2 are 1 and 2. And those are the positive and negative values. Now when you get a combination like this, you've got to make sure that you exhaust your list, that you make sure you pull up every possible candidate. So I know when I take all of these numbers and place them over the 1, I get the same numbers. So that'll give me 1, 2, 4, and 8. And again, that'll be the positive and negative values of that. And let's see if there's any other values. Now if I take this 1 and place it over a 2, I'm going to have an additional root, or candidate I should say, of 1/2. And let's see if I can form any other fractions. 1 over 2, 2 over 2 is 1, I already have it. 4 over 2 is 2, I already have it. 8 over 2, I already have it. So really the only additional possible 0 is 1/2. So now again I'm going to take and pull out the coefficients, remove the variables, and go through this process of synthetic division looking for the zeros of the function. Here's my numbers. I have 1, 2, 3, 4, 5, and that's the positive values, and the negative make it 10. So I really have 10 possible candidates that could give me the zeros that I'm looking for. And in this case, I'm not really sure if there even are any roots, but we can go ahead and see if there are. I'll start with the number 1. Drop down, that gives me 2. Those add up to -7. 1 times negative 7 is negative 7, and I can stop right there because I know I'm not going to get a 0 out of that. Sometimes you can just stop halfway through when you realize that that's not going to give you what you're looking for. So let's change that to a negative 1. Drop down the 2, negative 2, negative 11, positive 11. That gives me a 0. And then when I add that 0, I get 8. And then once again, I'm looking for that number to be equal to a 0. So once again, back to the drawing board, we've got to scratch that off our list. And we will go with the number 2. And again, repeat this process. Now I will tell you that there are no rational roots to this one. We could go down this entire list and we would not find a rational 0. I simply know that because I looked at the answers. So we could exhaust this list and I could keep going, but I'm just going to tell you that none of these zeros will work. Now, does that mean that we don't have any solutions? No, that does not mean that, because this number 3 tells me that I have 3 zeros of the function. They don't have to be rational. They can be irrational or they can be imaginary. So in this case, it looks like they're either imaginary roots or irrational roots. So we will go to the next problem, number 5. And again, this one has a nice leading coefficient of 1, so we're just going to take the factors of 16 and form our list. And we'll have 1 times 16, 2 times 8, 4 times 4. That gives me a total of 10 possible candidates. And again, I'm going to divide using synthetic division. And let's start with the number 1. 1 times 1 is 1. It gives me 3. 1 times 3 is 3. It gives me negative 5. Negative 5. Okay, that doesn't add up to 0, so back to the drawing board. Strike the number 1 off your list. And let's try negative 1. 1 times negative 1 is negative 1. Add those together, we get 1. Negative 1 times 1 is, again, negative 1. Add those together, we get negative 9. Multiply those together, we get a positive 9. We know that's not going to equal 0, so there's no need to go any further. And let's try a negative 2. Again, these are just random off this list. And you sometimes can try every single number like we did in problem number 4, and none of them will work. So this theorem only gives us candidates for that. If I start synthetically dividing now, I get negative 2 times 1, which is negative 2. Add those together, I get 0. Negative 2 times 0 is 0. Add those together, negative 8. Multiply those together, I get a positive 16. And yes, I have a winner. Negative 2 is a rational 0, so let's add that to our list. Remember, this is a third degree equation, so we could have up to 3 rational zeros. What I'd like to do next now is to rewrite this in polynomial form. So this is going to be x squared plus 0x minus 8. And that is a factor of this polynomial, which means I can set it equal to 0 and add 8 to both sides. And I can see that x is going to equal plus and minus the square root of 8, which simplified is plus and minus 2 times the square root of 2. And you can see that that is an irrational root. And in this problem, we're just looking for the rational roots. So the only rational root, or the 0, of this function is x equals negative 2. And we will be concluding this lesson.